So good afternoon again. So let us do some Matlab programming or the simulation of some problems with the help of the Matlab programming. So let us do one thing, that is your Matlab model with n-naught function using the Matlab program. I had given you in the first class, I had given you this AND gate, OR gate, and NOT gate. And NOT gate, as I have told you, that is basically x1 and x2 bar. NOT gate is basically x1 and x2 bar. That means it will be only 1 if it is x1 is 1 and x2 is 0. So in this case only it will be 1, and for other case it will be 0. So according to Matlab model, as you must be recalling that what is your Matlab model, we had given that if it is greater than threshold, then it will be 1. If it is less than threshold, then it will be 0. So let's try to write down. You have to just practice and you have to do it into your Matlab software. So I have written the program and I will show you in Matlab running the program. Then you have to do it yourself for the other gates. So first of all, we are giving that enter the weights, right? There are two weights because there are two inputs, that is your x1 and x2. There are two inputs and these inputs are going, so only there are two weights will be associated with it. So we have given the enter the weights. First of all, enter the weight W1 and enter the weight for W2. Next we are giving the threshold value theta. As you know, that is summation of xi into wi. If it is greater than equals to theta, then it will be 1 and it will be 0 if it is x1 wi, xi wi is less than theta. So we want the threshold value, so we are taking threshold value as theta. So this was the output, that is your weights, not weights, that is your just an array we have given, that is your for the actual response. Actual response or the output, we are taking one array, that is your y, that is equal to 0 0 0 0 we have initialized. Now we will go calculate one by one and we will be putting the value to y. This x1 and x2, this is basically this one, that is your x1 and x2. So x1 the array is 0 0 1 1 and x2 is your 0 1 0 1. So here it is 0 0 1 1 and 0 1 0 1. These are the two inputs. And target is your, again target is your 0 0 1 0. So this is your target, so I have given 0 0 1 0 and I have taken one value that is for counting the operation, that is your con equal to 1, that how many times the training will be done. If we get the target equal to the output response, then we will take con is equal to 0. After that only it will come out of the loop. So to be in a loop, we have given some counter or some condition, that is your con is equal to 1. So these are the inputs. This is my initialization, x1, x2 and target, and this is one value to take care of, that how many times it will be in a loop. Next, while con, that means while con is equal to 1, first time con is equal to 1. Now similarly we are giving zin equal to, that is your net, we are calculating x1 into w1 plus x2 into w2. That means we are calculating the zin, that is your net, right? This is x1 into w1 plus x2 into w2. So these two we are calculating. Now next is your for I is equal to 1 to 4. We have to check all the zin, right? Zin, all the zin we were to calculate. For zin I, if it is greater than equals to theta, then yi equal to 1, as the condition is that only. And if it is, because we will get 4 values, right? We'll get 4 values. This is your x1, this is your x2, this is your again x1, this is your again x2. So we will calculate for the 4 values. So that's why we have given, this is a very simplest way that we have given that for I is equal to 1 to 4 for all the Z in, right? For Z in 1, Z in 2, Z in 3 and Z in 4. Because here you will calculate Z in, you will get 4 values here. Here you will get, there will be the 4 values. Now for each and every value we are checking, if it is greater than equals to theta, then corresponding yi will be equal to 1, and if it is less than equals to theta, then corresponding yi will be equals to 0. Then it is your end and end, that is your if and this will be for end for for. After that we will display the output. That means total y we will display, that is your output, that is your display y. After that we have to check, right? That is your if y is equal to t, whether it is equal to t or not. If it is equal to target, then automatically our training is completed. Then we'll say con equal to 0 and it will come out of the loop, right? And if it is not equal to t, that means if it is not equal to the target, then again the another set of weights we will giving, that is threshold value, and again finally enter weight, enter w and all this thing, threshold and theta, and again the this con, that means again it will come to this loop and again the operation will be going on. So this is actually with the help of the Matlab programming how the simplest method of AND NOT operation can be done. Now let us see that, let me just copy it into the Matlab environment, and then let us see that how it will get. I suppose that this is already in my, you know, this I have already saved it in Matlab environment. So this is whatever I have written there, I have just copied it and pasted it into the Matlab programming. Now here we have to give the weight, enter the weight, and for example threshold value and all these things, and finally the output will be given. Now it is asking that enter weight W1, whatever you want to give. For example, I am giving 1. Then and enter weight W2, again I am giving 1. Then it is giving the theta or the threshold value. Let me give it as, for example, 0.5, right? So it is giving 0, 1, 1, 1. Net is your 0, 1, 1, 1, and finally definitely that is your output. It is not same as your the target, because target is what? 0, 0, 1, 0. So it is asking me again enter the weight. Now again let us give the enter the 1, and again W2 let me give it as -1, and the theta I am giving as a -1. Then that means it is giving that output of net is 1, 1, 1, 1. That means again you set the enter the weights. Now this way you have to find out that for which you know the weight it will be same as your you know from it will match the you know the target, and it will at for which values of w or theta it will match the target, and finally you can come to the conclusion. So similar things if we want to do, for example whatever we have done in case of the AND gate or the OR gate, then you can do it yourself, that what will be the for the AND gate, for OR gate, and for XOR function. This is the task you have to do. So I suppose that there is not a problem to understand this, that how to you know enter the weights, and how to enter theta, and how to enter the you know the inputs, and finally you will get the output, how to check, and how to check with your target, and how to give the different values of weight. Because for the AND gate and OR gate, you know what will be the values of weight that we have done in the calculations, that for AND gate it will be 1, 1 and theta will be equal to 1.5, right? For OR gate we have done that is 1, 1 and 0.5, right? For AND NOT gate it was a task for you, that for what will be the for AND NOT. I don't remember exactly that what will be the for AND NOT, that's why I have not given the actual data. That you can give whatever you have found out for AND NOT gate, that you can give it here. But AND and OR you know, so this type of problem you can do it and you can calculate for the AND or OR. And also you can do it for, you write the program for the XOR function. XOR also, you know that first of all you have to give the two sets. One set is for the OR operation, another set is for the NAND operation, and finally you will get the weights. You have to give the weights for the final AND operation. So this will be the OR, NAND and AND. So this times of weights you have to give. For the OR operation also you have to enter the weights. For the NAND operation also you have to enter the weights. And finally the AND operation also you have to enter the weights. And then you have to do the training and training. It will go on again and again. And finally the McCulloch-Pitts neuron model, what will be the your output, that you can find out, right? So this will be your task. Next, as I have told you that Hebbian learning, right? I had told you in the yesterday class that we will learn about more about the Hebbian learning. We have just learned that Hebbian learning only depends on the output values, right? Last class, yesterday's in the afternoon session, we have learned about the delta learning, but I didn't tell about the Hebbian learning. Now let's understand that what do you mean by the Hebbian learning, what it says. Now it is telling that we'll do the Matlab programming also, and it is telling that in the Hebbian learning, for example, there are this is your x1. Let me check the color, change the color. Okay, so this is your x1, this is your x2, that is your 1 1, right? Then 1 0, 0 is been represented as -1, then 0 and 1, then 0 and 0, right? So this is your bias. Bias we have taken as 1. Everywhere we have taken as 1 only, we will not change. And the output we have given, that is for the AND gate, that is 1 and 2 1, that will be 1. And otherwise everywhere we will get the 0, and 0 has been represented in bipolar mode, 0 has been represented as -1, right? So first of all, the step is, first of all, weight should be equal to 0, as we have done in the perceptron, that weight will be equal to 0 and B also equal to 0, right? Now weight change, Hebbian learning, it is telling that delta Wi will be directly depend on output, that is your Y. Till now we had done that it will be, you know, Xi into Wi, then it will be checked with the threshold value. Now we are telling that delta Wi will be changing, but it will be directly dependent on the Y. If you are getting Y as 1, then 1 will be multiplied with Xi. If you are getting Y as 0, then 0 will be multiplied with Xi. And delta B is equal to Y. This is the rule. You have to check this rule, and you have to abide by this rule, that in case of Hebbian learning, the change of W is equal to, the formula is Xi into Y, and for delta B it is equal to Y. That means change of bias. Now let us see what will happen. First of all, W1, W2 is was equal to 0. This was 0 and this was also 0. Now first, for the first time, that is your x1 equal to 1, x2 equal to 1, bias equal to 1, and the target is also 1. Right? Now, what will be the delta W? This is your target, right? Delta W is what I have said, that Xi into Y, right? Whatever Y you have got, that into Xi. That means Xi is equal to 1, 1 into 1, that is equal to 1. Delta W is equal to, what is the formula? That is delta W2, it will be X2 into Y, right? Now we are getting X2 into Y, that is your again 1, right? Delta B, they are telling that delta B equal to Y. That means Y in our case is 1 only. So we are giving delta B is equal to also 1. If it is like this, then what will be the W1 then? W1 will be previous W, that was 0, plus delta W1. That means 1. Here also we will get 1. B also will be previous one, that was 0. 0 plus 1 is equal to 1. Right? That was our first one. Next you go to the next one, that is your 1 minus 1, that is your 1 and 0, that was this one, right? Bias equal to 1 and the output equal to 1, minus 1. So this is our target, that is your minus 1. So delta W1 will be what? That is your x1 into y. directly it depends on y. So 1 into minus 1 equal to 1. Here also minus 1 into minus 1, that will be is equal to 1. Delta b is equal to only y is equal to minus 1. So delta b is equal to minus 1. Similarly, again we will calculate w1, that is be 1 plus delta w1, that will be 1 minus 1, that will be 0. Here it will be 1 plus 1, that will be 2. Here it is 1 minus 1, that will be equal to 0. Like this we will calculate, and finally the weights can be calculated as, that is your 2 and 2, and the bias is equal to minus 2. That they are giving the weights. And similarly we will train again and again. So let us do a Matlab program for the Heavian net or the Heavian learning to classify this two-dimensional input pattern. This input pattern is given to you, that is your first pattern is E that you are selling, you are giving, that is your E, and that is your F, right? This is your F and this is your E, that pattern we have given, right? So we have taken the two classifier. First of all, we are taking that if E is we get E, then the target is equal to plus 1, and if we get F, then our target is equal to minus 1. There are two classification. One is your C1, another is your C2. C1 is for E and C2 is for F. There are two classes, right? And we are telling that C1, we will get C1 if the target equal to 1, and it will be C2 if the target equal to minus 1. That we are considering that, right? Now let us write the program. So we have E input we have given. You can give the E or F as an input, or you can take the X as an input values also, right? So we are giving, that is your target. E and F is a target value, right? So what we are giving, that E means 1 1 1 1, right? First of all 1 1 1 1, because star is there. In the next 1 0 0 0, because these are blank, right? 1 0 0 0, then 1 1 1 1, that was only we are writing 1 1 1 1, 1 0 0 0, 0 represented minus 1, 1 1 1 1, up to this we have come. Then again next one 1 minus 1 minus 1 minus 1, and then 1 1 1 1, that is 1 minus 1 minus 1 minus 1, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Here I have given the, this should not be there, 1 1 1 1, that should be there, 1 1 1 1, this should not be there, right? This should not be there. Next again, that is your F. Similarly we can write, sorry, similarly we have written 1 1 1 1, 1 minus 1 minus 1 minus 1, 1 1 1 1, then 1 minus 1 minus 1 minus 1, 1 minus 1 minus 1 minus 1. So this way we have written every values, 1 minus 1 minus 1 minus 1, all these values we have inputted, that is your as your E and F. That means this type of pattern I should get, right? Now you are inputting the values, because you don't know that what input you will be giving. You have to check that whether it is under E or whether it is under F, right? Whether it belongs to C1 or whether it belongs to C2. Now input values, we have to give the, how many values? We have to give the 20 values. 1 2 1 2 3 4, 1 2 3 4 5, that means 4 into 5 20. Here also we will get the 20, that means 20 20 40 values you have to enter in X, right? Input values means that 40 values you have to enter. First 20 will be calculating for C1, second values will be calculating for, second 20 will be calculating for C2. Now first of all, W1 to 20 we are giving 0, because first 20 we are calculating, so we were giving that all the inputs are 0. Target we have given, target is equal to 1 and minus 1, that means we have given target equal to plus 1 and minus 1. So we have written, sorry, so we have written 1 and minus 1, and bias equal to 0, because first of all weights and bias, both of them should be equal to 0. Now we are taking 1 to 20, first 20 values we will be updating, right? Wi equal to, as you know, that the delta W is equal to, we have now come to know, that is your xi into y, right? Y is your target. Y is your target. Here I have seen that this y means what? This is your target, right? So target we have, that is your 1 for the first case, first 20 case, and second 20 case we have the target equal to -1. So first of all we are taking T1 for how many numbers? 1 to 20. First 20 values we are taking as T1 as your y. Xi, whatever xi you have inputted, that is your, through this you have input the 40 values, so first 20 values. B is equal to B plus T1, because we know that B, this is your delta W, and delta B is equal to only y, or target, right? So this is our delta B, and this is your old B, then this is your new B. Similarly, this is your new W, this is your the old W, and this will be your this into this, that is your delta W. So that we will do one by one, and finally we will be getting that for 21 to 40. This is for another variable. So we are getting I is equal to 21 to 40. Again we are calculating Wj, and this we are taking the two values, because Wj and the xi, that should be different. That's why we are taking j, because we want that W1, W2, W3, W4 for the second case, but xi should be 21 to 40. So we have taken the two variables, that is your I and j. Now we have calculated B, we have calculated j, and it will be gone for 21 to 40. Now we will describe that what will be the weight matrix, what will be the bias, what will be the display B. So that we have done with the Hebbian learning method. So same method, whatever I have shown here, that way we have calculated the final weights of the Hebbian learning and the final bias of Hebbian learning method. So you can try this, you can just write it down. That is your I'm just deleting all the erase. So you can just write, this is your Hebs net to classify two-dimensional input. I'm giving you just 5 minutes so that you can just note it down, that how we have given the input pattern, and how we are inputting the values, and how it will be, finally the weights will be calculated one by one. So this is your W1 to 20 equal to 0. I'm giving the 5 minutes for each slide. You can just note it down and you have to just try it, right? So this is your W, this is your target, this is your bias, this is your loop, that is your for the first case, that is your for C1, and this is your B, and this is the final end. And similarly for the other case, that also you can note it down. This is for j is equal to 1 for getting the values W1, 2, 3, 4, and this is your I, that is your 21 to 40, right? Finally, you can calculate the weight matrix and display the weight, display the bias, and this is your bias value, that is your B. Right? So this you think, first of all you can do this AND NOT operation. After that you can try for AND or OR operation, and then XOR operation. After that, with the Hebbian learning, you can just try that how to write the Hebbian learning and how to calculate the weight matrix. Now the AND function we want to write with the help of the perceptron. Perceptron, today morning only we have given the perceptron. So this is your AND function, writing a program for the AND function with the help of perceptron. Now again, that is 0, 0, that has been bipolar, that is your -1, -1 we have put, 0, 0 is means 0, 0, 1 is equal to 0, 1, 0 equal to also 0, and 1, 1 equal to 1. So this is our AND function, and let us see that how the perceptron algorithm can be written. So the X values, what are the X values? In the X values only, this is another x1 or x2 I have not written. This is another way of writing in one matrix only. So I have given the matrix as, this is your 1 1 minus 1 minus 1. Either you can write from the lower to upper, or you can write from upper to lower. That is 1 1 minus 1 and minus 1. Then 1 minus 1 1 minus 1. So this is only we have written. That is your 1 1 minus 1 minus 1 1 minus 1 1 minus 1. That will be your x, and this is my target. That is your target. According to this, we have written the target in this direction. So this is our target, right? Now let us consider that w is equal to 0 0, because there will be two weights, because two inputs, that's why the two weights are associated, and this will be b is equal to 0. Now here in perceptron, let me give you the values of learning rate also that we have taken in the morning, c equal to 1, but you can take the any learning rate. So I have given that you can input any learning rate value, 0.9, 0.6, whatever you want to give, and also the threshold value, right? Threshold value you can give whatever you want to give. You can give the threshold value 0.1, 0.2, whatever you want to give. So this is the starting, that is your, the loop will go on as we have done in the previous Matlab-Pitts model also, and finally we are initializing epoch, that is your one training or one iteration as a 0. Right? Now starting that while con is equal to true, right? If con is equal to true, we are giving this step. I will say that why we are giving this con is equal to 0. I will tell about. So while con is equal to true, that means first time con is equal to 1. That means it is coming to the loop. And for I is equal to 1 to 4, that means for the 4 values of I, what we are getting, that is your b plus bias plus x11 into w1 plus x21 into w2 for I is equal to 1, right? So you are calculating y, that y in, that is your net. That means your xi into wi plus beta or theta or b, whatever you want to give, right? Bias. So for the I is equal to 1, x1 into w1 plus x21, matlab there are two inputs, one is your x1 into w11 and x2 into w21. So there are two weights and the two inputs. We have calculated y in. If y in is greater than theta, then y is equal to 1. This was only one the concept, that if it is greater than equals to theta, then automatically your the value will be 1, and if it is less than equal to theta, then it will be 0. Right? So that way we have written the function, that net and the output, whatever according to this. Now if y minus ti, it says that if y equal to ti, if y is not equal to ti, that means if y greater than t or y less than t, both of them, these things will happen. That means in both the case, if y is equal to t, we know that there will be no weight adjustment. But if y greater than t or y less than t, in both the cases there will be the weight adjustment. So we have taken, you can write that if y not equals to ti, that also we can write, or we are writing that y minus ti, that means if y minus ti is positive or negative, it is not equal to 0, then again con equal to 1. That means, that's why previously we, sorry, I'm sorry. So that's why the previously what we are getting, that con equal to 0, we have given the con equal to 0, and this time we are giving that con equal to, again it will be equal to 1, so that it can continue into the loop. Now we are giving the weight updation. You have seen that we are giving the c, that is your alpha, that is your learning rate, into ti into xji. This should be ti minus weight. Here that should be written, I'm sorry, there should be ti minus y. This should be minus y, then is your xji, right? There will be two, there will be modifications here. That will be not directly as target, it will be ti minus y, right? After that only you have to just write into x. We have written, that is perceptron, we want that c into t minus y into xi, that we have got already. So here it will be ti minus y, whatever output you are getting, that you have to give into xji, right? Then is equal to, if it is a plus, then it will be plus. If it is a minus, then it will be minus. Automatically it will be minus. If target is greater than y, then it will be plus. If target is less than y, then it will be minus. Then after that you calculate the b also, and after that you calculate that epoch, you just increase the iteration, and finally again it will go again and again, and final weight matrix, when the con is, if y is equal to t, it will come out and it will give the final weight matrix. So this way you can just write the perceptron algorithm for the other matrices also. And for example, that we have written for the AND function, you can write for the other functions, and you can just do it. If you do it yourself, then only the you can just realize that what is happening. Otherwise, with the help of this PPTs, generally you cannot understand the Matlab programming. So I will give you the 1 hour time. You can just do all these calculations, all these programs, and after 1 hour again I will meet. I will be here only, and if you find any difficulty, then I will get back to you, and after 1 hour again I will meet you. So this is your actually that perceptron I have shown with the AND operation, and this is your task. Kindly note down this problem. This is your classification problem. These are the 1, 2, 3, 4, 5, 6, 7, 8. 8 inputs are there for x1 and x2. This was from the book only, from that is Rajashekaran. So there was a problem that I have given here only. So these outputs is given. So you have to iterate with the help of this perceptron, right? You have to write the programming, and you have to just tell me that what will be the final weights of this perceptron. You just write down this, and you the method I have given you, this method. So you must have written this method, and you can just try this method, and with the help of this method you can just try this to solve the problem, and finally you have to tell me that what will be the final weight. Next, any another network we can do, that is your Adeline network. That is also for the OR function I have given Matlab program for the OR function. That is also the same as your, you know, the AND operation for the perceptron only. Only the learning method is your delta W and delta W1 that I have given. That is your, here I have given, that is your alpha into Ti minus net Yi into x1. That the formula I have given in the morning, those formula only I have used in case of this. Now you can delta B also I have given, that is your delta B. So you can just check it with your previous classes notes, whatever I have taught into the previous session. Then you can try it. If you cannot get it, or in the Matlab if you are getting any difficulty, then you can just tell me, then we will do it again. Right. So these are the some Matlab networks or Matlab programming, but Matlab programming, it is not possible to, you know, to just read it and to you will be understanding that it is not the case. But whenever you will do the you know, programming, then only it will be clear. So my request is this: whatever you have noted down, you can just do it. I will be sitting here only. If any center wants to write down any slide, I will show the slide, you can note it down, and then you can try on your laptop or on your laboratory, whatever you want. If you want to note down, you can just tell me this slide or that slide. I will show you the slide, you can note down the slide, and you can just try it. And after 1 hour again at not 1 hour, at 3:45 again I will be here. I am here only, I am sitting here. Anytime you can discuss with me if you get any problem. Right? So the problem I have given to you, first of all, you have to solve the AND operation and the XOR operation using the Matlab model, and then with the Hebb's learning you have to just try it, that what will be the final weight. You can just try this classification, and then with the help of this perceptron you can do it, this equation, that is your this problem you can find out with perceptron. Then again you can do with your Adeline network. So this you can do with your Adeline network. So okay, then let us see that how you do it with the help of this Matlab programming. And any help you want, I'll be here. Then you can just ask me for any slide or any help. Okay, you must have done something. The remote centers, one by one. Let me ask Maharaja Surajmal.
Hello.
Hanji ma'am.
Ma'am, we have done actually Adeline for OR function, and we have drawn the error plot also.
Okay.
And then I think we have done one more perceptron
Okay.
learning for this. So we are
Okay.
able to do only these two programs actually.
No problem, no problem. You must have, that is actually basic idea is that not only the just telling you something whatever it is in the slide. So that
Yeah.
must be something, if you do something also in your laptop, then also you will get the essence of it. So that
Yeah,
was my
actually,
motive. That's why I had given just the enough time. I cannot give because up to 4 only the course time is there. So you can just extend up to 5 o'clock or 6 o'clock. You can do it yourself. And if you find any problem, you can discuss with me tomorrow also
okay,
or day
actually
after tomorrow.
we have given the programs to the faculty, and then they will try, and if some problem if
Yeah,
some
we'll
problem
definitely,
occur, then we will ask you.
discuss. You do it yourself, all the remote centers participants, because I suppose that this 45 minutes is not enough to do all these programs. So you have the PPTs with you. You can just try exact PPTs, exact whatever we have written. I have written in the program that you can try. After that, you can try the new programs, and we can discuss on Thursday again. If you find any difficulty, we can discuss it again, right?
Hello.
Hello, yes ma'am.
Madam, I was just doing that and not whatever you had given. So in
Yeah.
this and not the output should not be 0000. It should
No, no,
be
no. It should be 0010.
0.
0010. Only for one value, 1 and 0, the output will be 1.
And in case, see, if you look at your program, if the condition is 0, if y, the output is equal to the target, then the con should be equal to 0 and it should stop here itself. But
Yeah.
in the Matlab, it is showing another, you enter the another set of weights. Why?
I'm not getting it. You just tell me again.
If the output is equal to the target,
Hmm.
in that case, the program should stop.
Yeah.
But in the Matlab, it is showing enter another set of weights and threshold values.
No, it should stop when the target value we obtain. That time it should stop. That means if you give W1 and W2 as 1 minus 1, and the theta is also you give as -1, then I suppose that target should come. You can just check it.
I'll just check it out. Let's see.
If it is not coming output, it is again asking. That means somewhere in the loop it may be problem. You can just check the program.
So, see, it is saying the enter another set of weights and threshold values. So, in that case, can take the condition if T is target is equal to 1 and output is equal to 0. In that case, you have explained in the first class, in the earlier class, that you have to find out the new weight value by adding the P with the new weight, with the old weight.
You see, the stopping condition will come here. Stopping condition is your if y equal to t, that means if the target is equal to y, then con is equal to 0. If con is equal to 0, then means it will come out of the loop.
If it is not?
If it is not, then again it will ask another set of weights.
So in that, no, that is what I am asking, that should I go for a hit and trial method for using the weight?
Yeah. In case of Mac-Culloch's model, we don't have anything that we can update the weight.
Achha.
We cannot update the weight in Mac-Kulak-Pitt model. You just remember in the first class I have told, in Mac-Kulak-Pitt model you have to just enter it and you have to give. But from perceptron onwards, this is your learning scheme, and for the perceptron onwards we are getting the learning rule and we are getting the updating rule of the weights.
Okay, fine. Thank you.
Right? Okay.